Okay, so we're going to talk about the major concepts when we talk about describing the center of data sets. So when we talk about measures of center, the main one that you'll hear a lot is the mean. Um, now, there are two different means. There's several actually different means that you can compute. But if you're just talking about a mean, right, nothing super special about it, there are two. One of them is X bar, and we call this X bar. It's got X with just a little bar on top of it. And this is a sample mean. Now, when they're talking about sample again, it's if you're picking people from a population, right? You're picking items from a population of all of items. So pretty much everything is a sample. Right? Otherwise if you're testing everything or finding everything out about everything, that's a census. A little bit different, but most things we deal with are going to be samples. Now, um, we do, however, refer when we talk about means to the population mean, sorry, which that would be like the true mean. So for example, let's say, I know, fact, you know, uh, the average height of Americans is 6 foot. All right, let's say that that's a fact. Just go with me on this. Not really a fact, but I'm just saying that just for the sake of my argument. All right. Well, in that case, our mu would be 6 feet, right? That's the actual average. That's the mean, right? That's true. Um, that would be different than if I took a sample mean, right? Like if I were to say that, I went and found, 100 people and averaged their heights and found them to have an average height of 6 feet. Well, that's a sample mean, right? Because it's not the true amount. The true amount is what it would actually be. Very, very rarely do we actually know the true mean of stuff because you would have to have a ton of measurements for any population of any big size. You'd have to have that. But that's the main difference between these two types of means. Median, pretty easy to understand. It's the middle data point. So it's just the middle data point. Now, obviously, they have to be ordered first. Now, there's no symbol for median. We just refer to it as median. Um, it's not used in many of our calculations. You can use it if you want to substitute that for a mean or something, but it doesn't have a symbol on its own, and it's not really used for calculations. It's used for kind of comparing how a distribution looks. Main thing is if you have an odd number of observations, then it's the middle point. If it's even, then you average the two middle points. That's the biggest concept with that. But I think everybody's pretty familiar with that from school. So if we compare the mean and median, what do they tell us? Well, if the mean and the median are the same, then that's going to imply that you have a symmetric distribution because you not only have your mean directly at half of your data, but your median, but um, half of your data is above, half of your data is below, and your mean is right in the middle. So it's got to be symmetric on some level. It just pretty much needs to be. Now, if your median is lower than your mean, well, let's think about what that actually means right now. Well, half of my data is this way, and half is the other way. Well, if my mean is on the upper half, then that means that it's carrying some extra weight. So there are some extra observations, some big observations that are different than the majority, right? The majority is obviously going to be, around where the median is or below. That's where most of the observations occur. So you're having fewer big observations stretching it. So this creates a skew right, or you can call it skewed right. That means that it's got a tail going off to the right. So again, this is symmetric. Now, if the mean is lower than the median, then that means that half of our data is above the median again, but our mean is located in the lower half of our data, the lower half, which means that this is going to be skewed left. Now, a trimmed mean, this is pretty easy concept. I'm not going to get fancy with my numbers here, but I'm just going to say 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. And instead of 9, let's say I'm just going to do 20. Okay. Well, let me do an average here real quick of these numbers. Okay. If I just did the mean of these numbers, I've got 3 plus 7, so that's 10. I've got 11 plus 15 plus 20. So we got 35, 21. So this is 56. So I've got 56 as my sum for all of these. And I've got 10 numbers. So my average is 5.5. So, excuse me. So my mean here is 5.5. So this is just a sample of stuff, right? I'm not population. This is just a sample of numbers I picked out of my head. So, oops, not 5.5, 5.6. Okay, so there we go there. Pretty easy. Okay, well, if I wanted to do a trimmed mean, and again, there's not a symbol for it, but my trimmed mean, what I'm going to do is I'm going to take off numbers from both the low side and the high side. And I got to take off the same number. And you'll see a percentage associated with it. It's the percentage taken from each side. So I'm going to write this up here so that I have room. So x bar is 5.6. Okay, so it's the same percentage. I've got 10 numbers. So it seems like this is the only one that's really out of character. So I want to eliminate that. But I need to also eliminate my 0 because to be fair, I have to eliminate a low value as well. So I have to trim from both the top and the bottom in order to make this more even for myself. Well, 20 represents 10% of my data, right? And so does 0, 10%. So even though I'm cutting out 20% of my data, I'm actually cutting off 10% from each side. So this is a 10% trimmed mean. So that's 10% from each side. Right? That's very important. So if I redid the mean here, again I've got 3, 7, 11, 15. So that's 10. That's 26. So that's 36 divided by 8. Well, this is 4.5. Right? I've got a much lower number now than I did before because that 20 was skyrocketing it up. Okay, so that's what a trimmed mean is. It can help us get better data. We just got to make sure that when we say 10%, it's not 10% of the observations. It's 10% from the top and 10% from the bottom. So it's really 20% that you're taking away. And our last thing is sample proportions. This is just, these are just categories, successes versus failures, or, made versus missed free throws, or whatever it is that you want to think about. If, you know, if we've got our guy, well, he can't shoot. He's terrible. Ah, he's got terrible form. Look at him shooting the ball. Right, we got our goal. Kind of, wish I knew how to draw. Right? Let's say he goes, make, no, I shouldn't do that. I should go, so he gets 1 point on his first, 0 on his second because he missed, 1 point on his third, 1 point on his fourth, and then he misses 2 in a row. Okay? Or, well, Yeah, he misses 2 in a row. Well, if we were looking for his sample proportion of makes, so, and we use this symbol p hat, right? It's sample proportion. P stands for proportion. The hat stands for that it's a sample, or that's a kind of an estimate, right? So here, if we're looking for how much he's made, we look for the number of successes over the total. So it's just like any sport, right, where you're taking the amount of makes versus divided by the amount total. That's what a sample proportion is. If you can just think about, field goal percentage or completion percentage or any, batting average or anything like that, those are all sample proportions. So here you've got 3 makes over 6 total, which is 0.5. So he's a 50% free throw shooter, which is awful. But for the sake of our purposes, it works out. So that's what a sample proportion is. It's super simple. Just think about sports when you do that, and you'll have no issues with it.